Let me check whether my screen is visible. Okay. So here's the intro of chemical reaction. So before starting the chapter, tell me what is physical change and chemical change?
Physical change means like changing state of what chemical reaction is the formula of the substance is changing.
Please be loud.
Chemical reaction means the chemical formula of the substance is changed after the reaction, but physical change means the chemical formula of the substance is changed.
Okay. So basically, what happens during a chemical change, a new substance is formed, right? Which is irreversible, right? Which is irreversible. So the change in which a new substance is forming is known as physical change. And the new substance properties is very much different from the previous one, right? From the original one, the new substance properties is very much different. But in physical properties, what happens? There is no formation of a new substance, right? Like, see, what is chemical reaction? It is a process in which one or more reactants are converted into one or more products, right? See, just a second. Yeah. So what happens? What is chemical reaction? So when, for example, A plus B, these reacts to form C plus D, right? So what happens here? One or more reactants. What are these? These A plus B are known as reactants, right? These are reactants which are reacting to form new substance which is C and D, right? And C plus D, these are known as products. These are known as products. So basically, during a chemical reaction, chemical changes takes place. And the substance that undergoes chemical change are called reactants, right? Like here, A and B, these substances undergo a chemical change and it forms C and D product, right? And the new product, what are new products formed after the reaction between A and B? C and D are formed, right? So C and D, these new substances that are being formed is known as product. Okay? So in this case, there are two products, C and D. And how many reactants are there? A plus B. Two reactants are there and two products are there. Clear? And see, this, we write the product on the right side of this arrow and on the reactants on the left side of this arrow. Okay? Like this is CH4, methane. When it reacts with oxygen, it forms carbon dioxide and it releases water, right? So what are reactants here? Reactants is methane, CH4 and oxygen, right? And what are products here? Carbon dioxide and water. Get it? Clear, bache? If there is any doubt, you can stop me and ask to repeat, okay? I will repeat it. So what are chemical changes? The transformation of a chemical substance into another chemical substance are known as chemical changes or chemical reactions you can call. Okay. Another example is rusting of iron, right? And can you please give me some more examples of chemical reactions? Setting of curd, right? Formation of curd from milk. It is also example of chemical reaction, right? Another example, tell me. There are
Burning of
more examples.
magnesium dependent oxygen,
Yes.
burning of magnesium dependent air,
Or more examples. Cooking of food, right? Digestion of food, respiration, it is also a chemical change. There are more examples in day-to-day life. Okay. Now see what happens in a chemical reaction. what happens? A new substance is formed, right? And the properties of a new substance is completely different from the original one. Like here, these A and B, for example, this methane and oxygen, it reacts to form carbon dioxide and water, right? So the properties of methane and oxygen is totally different from this carbon dioxide and water, right? Got it? Clear, bachche? Okay. Like see here, this is an example of a chemical reaction. So when you burn a clean magnesium ribbon, right? So see the reaction between this. When magnesium, which is in solid form, and it reacts with oxygen, right? Combustion occurs in the presence of oxygen, right? Oxygen support combustion. So Mg plus O2, it will form magnesium oxide, right? Which is a white powder, white color powder. Okay, and this magnesium ribbon burns with a dazzling white flame, and it forms magnesium oxide, which is a chemical reaction, example of a chemical reaction. Have you performed this experiment in your lab in your previous class? No? Okay, no problem. So when you react magnesium with oxygen, it forms MgO, magnesium oxide. And this, the properties of magnesium oxide is totally different from this magnesium and oxygen. Okay, clear? So it's our best example of chemical reaction. And yeah, tell me, Uche, uh, and say here's a question. Write down the question. So before burning, write down. I'm dictating. Before burning in air, before burning in air, the magnesium ribbon is cleaned by rubbing with sandpaper. Before,
What?
before, before burning in air, the magnesium ribbon is cleaned by rubbing with sandpaper. Give reason. Give reason. Why it happens? See, because on the magnesium ribbon, there is a protective layer of basic magnesium carbonate, right? On this magnesium ribbon, there is a
Mm.
there is a basic magnesium MgC, magnesium carbonate. Hmm. Okay, write down the answer. What happens? What will be the reason? Write down the answer. To remove, to remove the protective layer, to remove the protective layer of basic magnesium carbonate, to remove the protective layer of basic magnesium carbonate from the surface of magnesium ribbon, from the surface of magnesium ribbon. Okay, that's the answer, right? So that's why we first clean the magnesium ribbon by a sandpaper, okay, to remove the protective layer of magnesium carbonate from it, okay, so that the combustion takes place, okay, so that it can react with oxygen. Mg plus O2, it will give you magnesium oxide. Clear, bachche? Clear, Umair?
Teacher, my name is Umair.
Yeah?
My name is Umair.
Umair?
Yeah,
What did you say?
my name is Umair Nambuji.
Umair Rimson, right?
Yeah.
Okay. Okay,
Oh, I
next.
heard you calling me Buji.
What?
My name is Umair Insan, not Buji. Buji.
No, I told you bachche. It means child. Right, child. Yes. Okay, Umair. I will call you by your name, Umair.
I
Okay,
thought
so
you was calling
tell
me by
me.
name.
Okay, tell me, Umair. In this reaction, what are reactants and what are product? Tell me the reactant name and the product name.
Magnesium and oxygen is product reaction, reactants, and magnesium oxide is the product.
Yes, good. These are reactants, right? Because they are reacting, and magnesium oxide is product here. Got it? Okay. Next example is the reaction between lead nitrate, right? So see what happens. So this is an experiment in which you have to take the lead nitrate PbNO3, right, in a test tube. Take a test tube and just put a small amount of lead nitrate in it. After that, add potassium iodide. What is potassium iodide? Ki, right? Potassium iodide to the solution. What will happen when the lead nitrate and potassium iodide reacts? It will form a yellow colored precipitate. Yellow colored PPT you will get, which is of lead iodide, right? So see here. So this is a lead nitrate solution. This white crystal is lead nitrate solution, right? And what we are doing is just adding, we are adding potassium iodide, Ki solution to it. So when you add potassium iodide solution to the lead nitrate solution, what happens? There will be a reaction between potassium iodide and lead nitrate, and you will get a precipitate here. See, this is a yellow colored precipitate in the bottom of this container, right? So you will get this yellow colored precipitate is of lead iodide. This is lead iodide, right?
Mm.
Here, when you will perform in
Yes,
your lab, it will be more clear. It's the chemistry is very interesting, right? Do you like chemistry? Do you like chemistry, Umair? Which
yes,
subject you like most?
bio.
I okay. That's also interesting. What's your aim in your life? You want to become a doctor? Okay, see. So I hope it is clear what happens here when we take lead nitrate solution and uh, when we add potassium iodide solution to it, a yellow colored precipitate forms, right? A yellow colored lead iodide precipitate forms, and this shows a chemical changes. Chemical reaction happens here, right? Okay. See, another example is
Ma'am,
here.
what's precipitate?
What is precipitate? So basically, it is undissolved materials which are present in your bottom, right? PPT, precipitate. Solid particles, small solid particles which are undissolved in the solution. We will get precipitate over here. Okay,
Precipitate
just
is
like
the
see,
down arrow.
yeah, it will settle down
Then
here.
what's the up arrow?
Yes,
Precipitate is the down arrow, right?
yes, it is a down arrow. Like this is a lead iodide solution. So what you will write here in the chemical reaction, you will write just like that. This is precipitate of lead iodide. Okay,
Okay.
and for gas, you will write up arrow for gas form. Like whenever there is a formation of gas in a chemical reaction, just like H2, you will write arrow, right? Upward arrow in the bracket. It shows that H2 is a gas. Is in gas form. Okay, bachche? Okay, Umair. Next. Again, example of chemical reaction. Here, what happens? Zn, zinc is reacting with H2SO4. What is H2SO4? What's the name of H2SO4?
hydrogen sulfide.
Yes, but is it a acid or base?
Uh,
Is it a acid or base? H2SO4 is acid or base? What is this? H2SO4 is sulfuric acid. Very concentrated acid it is. Sulfuric acid, right? So when sulfuric acid is added to the zinc solution, yeah, for example, just take a H2SO4 in a beaker, right? H2SO4 acid in a beaker and add zinc granules to it, zinc particles to it. What will happen? H2SO zinc will react with H2SO4 and it will form zinc sulfate, right? And hydrogen will be liberate out. The hydrogen gas, H2 gas will be liberate out. And what is the sound of H2 gas? It always releases with a pop-up sound. Hydrogen gas always released by a pop-up sound, right?
okay.
So you can uh, distinguish this test. See, bubbles are observed around zinc granules. What you will observe, bubbles are observed around zinc granules. Why? Because the release of hydrogen gas. Okay, and the conical flask in which the chemical reactions are you are performing in the chemical reactions. What happens? The conical flask become hot, right? See, this is a conical flask. This is a conical flask. I'm repeating this experiment. What you have to do is just take a conical flask. This is the apparatus, chemical conical flask, and add take a dilute sulfuric acid to it, like 10 ml sulfuric acid, right? And add zinc granules to it, right? Zinc particles, zinc granules to it. What will happen? From here, the H2 gas will be liberate out with a pop-up sound, okay? And this conical flask, this whole conical flask, it will become hot, right? It will become hot. That uh, that is the characteristics of a chemical reaction, right? It's a exothermic reaction. Exothermic means the heat is being evolved. Heat is released. Okay, heat is released in the form of H2 gas. That's why you see the bubbles around the zinc granules. You will observe the bubbles here. See, when the reaction happen, you will see the bubbles around these granules. Okay, so this confirms that the chemical reaction has done and you will get a zinc sulfate. What happens when zinc is reacting with H2SO4 sulfuric acid? Here you will get ZnSO4 zinc sulfate plus H2 gas. Hydrogen gas will be liberated out. Okay, here is there any doubt in this reaction?
The conical flask will get heated only when H2O gas H2 gas releases or when any gas releases.
The gas will release out from here. The gas will release. This is a cork. This is a cork lid. And from here, this is a small pipe, glass tube. And from here, the gas will release out with a pop-up sound. You can
Then
just hear the pop-up sound.
no, like you said, the conical flask get heated. It's only
Yeah,
when the H2 gas releases or if any gas releases that it gets heated.
no. So it can happen when the reaction is exothermic. If any gas releases, then this container, this conical flask become hot. The reaction is exothermic, means energy is being released out, right? So you will feel the hot container. Conical flask become hot if the energy is being released. Here the energy is being released in the form of H2 gas, but in some other reaction, the energy is being released by the evolution of other gases too, right? So in that case also, the conical flask become hot. Okay, just remember that. Okay, bache? Okay, so the next. Yeah. So see, there's some observation that helps you to determine whether a chemical reaction has taken place or not. Like I said, we will see the evolution of gas, just like in this case, a gas, hydrogen gas is being evolved. That's how you can observe that the chemical reaction has happened, right? So there are some indications of a chemical reaction, right? So let's see one by one what are the indications. So see, first, there are some characteristics of a chemical reaction. Like first, you can see the chemical evolution of a gas. Like in the previous one, you see the evolution of gas. Hydrogen gas is being released. So that's how you can say that a chemical reaction has happened. Okay. See, evolution of gas. Another example is just, for example, zinc. Same example. When zinc granules is put it in H2SO4, it will it will give you ZnSO4 plus H2. Right. So here H2 gas is released. Right. H2 gas is being evolved from a pop-up by a pop-up sound. So this is a indication of a chemical reaction. You can get to know the reaction has happened by the release of this H2 gas. Right. And another observation is the change in state. When the chemical reaction has taken place, you can observe the change in state. For example, let's take an example like a chemical reaction between citric acid and potassium permanganate. See, example, citric acid. So citric acid plus and potassium permanganate. So see, potassium permanganate color is purple. It is a purple color solution. Potassium permanganate, intense purple color solution. So when a chemical reaction between citric acid and potassium permanganate, it is characterized by a change in color from purple to colorless. So see, the color of the potassium permanganate is purple, right? This solution is purple in color. But when you put citric acid to this purple color solution, what happens? The chemical reaction takes place and this purple color changes to colorless. Okay, got my point?
Citric acid, which color, ma'am?
Citric acid. Citric acid is a type of acid, weak acid. Like
No, what color
it
is
is
it?
found in lemon. Lemon.
What color is it?
Okay. Yes. It
What
is found
color
in
is it?
lemon.
Yes.
Okay. So according to your standard, you don't need to need the chemical reaction of that citric acid and potassium permanganate. Okay. So just remember the example. Change in color you will observe here from purple to colorless. When you add citric acid into potassium permanganate solution, the purple color solution it changes from purple to colorless. Okay, so that shows the color change, right? It's not a state change example. It's a color in change in color. You will observe the change in color of the solution from purple to colorless, right? So you can determine whether a chemical reaction has happened or not. Okay, so it's an indication that the chemical reaction has taken place. Okay, you can see the change in color. That's the indication of the chemical reaction that has taken place. Okay, Umair? Okay. Next is your, yeah, another example is, see, color, change in color. See, another example. When a reaction between sulfur dioxide gas and acidified potassium, dichromate solution means dichromate solution in an acidic form. Acidic potassium dichromate solution, right? acidic potassium dichromate solution. So see, in just take a acidic potassium dichromate solution and pass this sulfur dioxide gas into it. So what will happen? You will change the orange color solution to green. So it will form potassium dichromate solution when you pass sulfur dioxide gas to it. It forms a orange color, right? It will form, it is an orange color solution. When the chemical reaction taken place, the orange color changes to green, right? So you can observe the change in color. So you can say that the chemical reaction has happened. That's why you observe the change in color from orange to green. Clear? If not clear, then tell me. I will repeat. I will give
Clear,
some.
ma'am.
Clear? Okay.
Yeah.
Next is here you can also change. You can observe the change in state also, right? And yeah, see, in the same reaction, you can't see all the changes, all the four changes, right? These are the indication whether you can observe the change in state, or you can observe the color change, or you can observe the evolution of a gas, or either you can observe the change in temperature. You can't see all the indication in the same chemical reaction. Okay, okay. Now see the change in state of a substance. So you will observe the change in state. Like for example, combustion reaction of candle wax. See, when candle wax is being combusted, right? When this candle wax is getting combustion, so what happens? It is characterized by a change in state. It will it will change its state from solid to liquid first, right? See, when you apply temperature to candle wax, what happens? The solid, it will melt to form liquid, right? Right? And it will form a
Yes.
gas also. Some parts, it will form gas also. So it's a change in state, right? It's an example of change in state because the wax is a solid, right? And water formed by combustion of wax is a liquid at room temperature, right? Whereas the carbon dioxide, which is being produced by the combustion of gas, is a combustion of a wax is a gas. See what happens here. I said the wax is a solid, right? Wax is a solid, and the water formed by combustion of wax is a liquid, right? And in the combustion of a candle wax, there is a there is a evolution of carbon dioxide also, right? And we know that carbon dioxide is a gas. So we can say that the combustion of candle wax is characterized by a change in state from solid to liquid to gas. Clear?
Mm. Yes.
Done? Yeah. So just
Mm.
remember all these examples and what are the observations that helps you to determine whether a chemical reaction has happened or not. Okay. If a chemical reaction has taken place, you can observe a change in state or either the change in color or the evolution of a gas or the change in temperature.
Mm.
Okay. Now see examples of a chemical change in temperature. So see again when the zinc granules, see change in temperature, this examples which we have discussed earlier. This example, see. So here the change in temperature you have observed, right?
Yes.
You have observed the change in temperature because the conical flask after chemical reaction it becomes hot, right? The temperature increases, right?
Mm.
So the chemical reaction, again the same example you can write. the chemical reaction between zinc granules plus sulfuric acid, it will form ZnSO4 plus H2 gas will be liberated out. And here the temperature rises. You observe the rise in temperature. Temperature increases. This is increase sign. Okay. Okay, Umair?
Okay. Yes.
Okay, now see. So chemical reaction. What are chemical reaction? So chemical reaction is nothing but it is a representation of a chemical reaction. Chemical equations. See, what are chemical equation? It is a of representation of a chemical reaction using using symbols
Chemical symbols.
and formula and formula of a substance of a substance. So what are chemical equations? Chemical equations are the representation of a chemical reaction using symbols and formula of the substance, right? For example,
Mm.
and we have discussed that A, for example, A plus B, these will react to form C plus D, right? So what are A plus B? These are reactants. And what are C plus D? These are products. We have discussed it earlier. And see, this arrow, see Umair, this
Huh?
arrow shows the direction of a chemical reaction. It shows that the direction of a chemical reaction is in forward direction, right? And if there is any condition like heating at particular temperature, it is written over here. Generally, it is written above on the arrow. Okay. If there is a certain conditions like, for example, certain temperature like 70 to 80 degrees Celsius, so you will write over here on the arrow. Okay. If you are hitting the chemical reaction condition is hitting you, if you are hitting these two, so the conditions are written over this arrow only. Okay.
Okay.
Yeah. So here, for example, magnesium, it will react with oxygen to form magnesium oxide. What is the formula for magnesium oxide?
MgO2.
O2, MgO only, magnesium oxide, right? So this Mg, it will react with O2, it will form MgO, magnesium oxide. And this is an unbalanced chemical equation, right? We will get to know how to balance chemical equation and why there is a need to balance chemical equation, right? Now see, this is,
Yes.
see here, this is on the left hand side. So this is an arrow, and the product is always written on the right hand side of this arrow. And we write the reactants on the left side of the arrow. This is your LHS side, left hand side, and this is your RHS side. Okay. And this arrow shows the direction of the reaction, that the reaction is proceeding in this direction. Okay. Now see how to write a chemical reaction. So chemical reactions, these are class simplified by using chemical formula. Use chemical formula of all the elements. For that, you should know the symbol of every metals and every element. Okay, that's why I told you to memorize the periodic table from 1 to 20 at least element. Symbol is atomic number, atomic mass, valency, each and everything. Okay, now see,
I memorized
for
the
example,
atomic number, valency, and the symbol.
okay, write it down,
Just
write down the homework, write down your notebook. You can write it down in your notebook. Memorize periodic table from 1 to 20 elements. Atomic number, atomic bracket में you can write atomic number, symbol, atomic mass, electronic configuration, valency, and just write it down whether it's the element is metal or non-metal or metalloid. Okay. Also write the element is metal, non-metal or metalloids. Okay. Just write it down in the tabular form and please memorize these. It's very important because we are going to discuss the balanced chemical equation, how to balance chemical equation. So see, a chemical equation represents a chemical reaction. Like for example, this is a very basic example, an Mg magnesium. It is reacting with O2, it will form MgO, right? So if the number of atoms of each element is not same on LHS, like see here, this is the LHS side and this is RHS side, right? So here, which elements are there? Magnesium is there and oxygen is there. Magnesium and oxygen. And here also magnesium and oxygen. Okay, tell me, Umair, how many magnesium and how many oxygens are there on the left hand side?
1 magnesium, 2 oxygen.
And about the right hand side, how many magnesium?
1 magnesium, 1 oxygen.
So is this a balanced chemical equation?
No.
No. This is an unbalanced chemical equation, right? And the unbalanced chemical equation are also known as skeletal chemical equation. Okay, it is also known as this type of equation are known as a skeletal chemical equation. Okay, and if the number of atoms of each element is same on LHS and RHS side, then this type of equation is known as balanced chemical equation. Okay, this is a skeletal chemical equation, and what you have to do is, so this here magnesium is 1 and here also magnesium is 1. So we need to balance the oxygen atom, right? Oxygen atom. Okay, so what you have to do is, here 1 oxygen is there and here 2 oxygen is there. So just balance here 2 oxygen. So again check, this is 2 magnesium and 2 oxygen. So for 2 magnesium, just put 2 here, right? So there will be 2 magnesium, 2 magnesium. Here 2 oxygen and 2 oxygen. Okay, so this is a balanced chemical equation. That's how we balance a chemical equation. Okay, we will get to know, we will discuss it more briefly. Just okay. Now see, what is a law of conservation of mass? Law of conservation of mass. So see, law of conservation of mass, according to law of conservation of mass can neither be created nor be destroyed. Okay, in a chemical reaction, mass can neither be created, it can nor be destroyed. The total mass of the elements present in the product is equal to the total mass of the element in the reactants. See, it's very important. Concentrate here. So according to law of conservation of mass, what happens? Mass can neither be created nor be destroyed in a chemical reaction. Okay, which means the total mass of elements present in the product side is always equal to the total mass of the elements in the reactant side. Okay, means what does it mean? It means the number of atoms of each element remains the same before and after a chemical reaction. Okay, So that's why the skeletal chemical equation must be balanced, right? So why there is a need to balance a chemical equation?
because of the law of conservation.
Yeah, because of law of conservation of mass. Good. Now see, if I give you this zinc plus sulfuric acid, okay, in a word form, zinc, when it reacts with sulfuric acid, it will form zinc sulfate and hydrogen. Hydrogen. So first, what you have to do is just write down the skeletal chemical equation using the formula. You should know the formula of zinc, symbol of zinc. So what is the symbol of zinc? Zn. Okay. And what's the formula for sulfuric acid? Sulfuric acid is H2SO4. You should know all these. Okay. So what it will form? Zinc sulfate. From here, HC here. From here, H2 gas will be liberate out. And this SO4, it will goes to zinc, forming ZnSO4. Okay. Now check, is the this reaction, is this equation balanced or not? Here you can see that on the LHS side, zinc is 1, right? Here also, zinc is
It's
1.
balanced.
Yeah, it's balanced. So thus, it is a balanced chemical equation. Got it?
Yes.
Okay. So we will see, uh, okay, see another example, how to balance a chemical equations. For example, Fe. So we can balance a chemical equation by 2 to 3 methods. Like first, we will discuss the hit and trial method. Okay. So what you have to do is, this is Fe. When it is reacting with Rn is reacting with water, what happens? It will form ferric oxide, iron oxide, Fe3O4, and H2 gas will be liberated out. Okay. Now check. First, what you have to do is just draw the boxes around the formula. Draw the boxes around the formula. Okay. Now, list the number of atoms of different elements on the LHS side and on the RHS side as well. Okay, like on the LHS side, how many Fe are there, how many hydrogen are there, and how many oxygens are there. Okay, write it down. Similarly, on the RHS side. Okay, so tell me how many atoms of iron is there?
3Fe plus 4H2O is
And see
Fe3O4
this,
and
no, no, no.
4H2.
So tell me, this subscript is for only for iron. It shows the number of iron only. Okay? See,
Right?
Fe3, Fe3, right? Fe3 is this is subscript, right? See,
Mm.
this is on subscript. So this only shows the number of iron, not the number of oxygen. Okay, Umair? So in the
Yes, right.
on the RHS side, how many irons are there? There are only 3 irons.
One.
3 irons. No, not one. Here on the coefficient, there is nothing. That is one. But in the subscript, it is 3. So 3 into 1 is 3. Clear?
Mm. Mm.
Similarly, tell me how many oxygens are there?
4.
Yes, good. This is subscript. Subscript, this is subscript. On the subscript, it will show, it will tell you the number of oxygen atoms over here. And see, for example, Fe3O4. And if there is a coefficient 2, for suppose that if there is a coefficient 2, so how many irons are there? 3 into 2.
6.
Yes, good. How many oxygens are there? 4 into 2,
8.
8. Okay, now clear?
Ma'am, in school we studied to do without the graph.
Yeah.
In school we studied how to do without the graph.
Okay, okay. In school, you have done this?
Yeah, I can do this. by myself.
Okay. So how many RNs are there?
And the
See,
latest one.
LHS it is 1, right? And on the RHS it is 3, right? 3
Three.
RNs.
Yes.
And how many hydrogens are there? 2. And here
Two.
2.
Two.
And how many oxygens? Here 1. And here
One.
4 oxygens.
Four.
So there, it's a unbalanced chemical equation. So there is a need
Yes.
to balance this chemical equation. So how you will balance? How will you balance? See,
By multiplying.
so I will write down. I think the time is up. Okay, no problem. Let's do this question. After that, we will discuss briefly in the next class.
Okay.
So first, what you have to do is just write unbalanced equation. Write down in your notebook. You can write it down in your notebook. Write the unbalanced equation. So what is unbalanced equation here? Fe plus H2O. Fe, see, I'm writing over here.
It's H2O.
Hmm. Fe plus H2O, it will give you Fe3O4 plus H2. Okay, so first step will be write the unbalanced chemical equation. Now count the atoms. See, on the LHS side, on the RHS side. Write down all the element name like Fe, hydrogen and oxygen. Here also Fe, hydrogen and oxygen. Count the atoms of each element on both the sides of the equation. 1, here 3, here
Okay.
2, 2, here oxygen is 1 and 4. Okay, next step will be balance the elements. Okay, and start
Hmm.
with an element that appears in only one compound of each side of the equation. And yeah, see, just remember, Umair, you can only change coefficient. You can't change the
Hmm.
subscript, right? You can't
Okay.
change the subscript. You can only change the coefficient over
Okay.
here. Now balance,
Okay.
balance hydrogen iron first. How will you balance the iron? Here are 3 iron, so just put 3 over here. Okay. Now balance the hydrogen. Hydrogen is already balanced, right? Hydrogen is already balanced. Now balance oxygen. There are 4 oxygen over here, right? So what you have to do is just 4 coefficient, put the coefficient 4. So there are 4 oxygen, but also there are 8 hydrogen here, right? So for 8 hydrogen, just put 4 over here. 4 to the 8.
Hmm.
Now check, at last, just check out whether the equation is balanced or not. Now see here, on the
Hmm.
LHS side, there is 3 iron, right? 3
Hmm.
iron. And here on the RHS side, also there are 3 ions. Hydrogen, how
Yes.
many hydrogens are there? 4 to the 8 hydrogen. And here also 8 hydrogen. How many
Hmm.
oxygens are there? 4 oxygen, right? This coefficient is multiplied to all the elements, like for hydrogen and also for oxygen. You know, na? Okay. So there are 4 oxygen and 4 oxygen. So this is a balanced chemical equation. Okay.
Yes,
That's
ma'am.
how we balance a chemical equation. Okay. So we will do some more questions based on that, on balancing a chemical equation in the next class. Okay, I think the time is over for the next class. Okay, Umair, is there any doubt in today's session? Any doubt?
No, ma'am.
Everything is clear?
Yes.
Okay, please do your homework. Just memorize all the atomic number mass. Okay?
Okay.
Okay. Thank you. You can leave the class.